In this video, I would like to explain about PCM, which stands for pulse code modulation. PCM is a method used to convert an analog signal into a digital signal so that it can be transmitted through a digital communication network and then converted it back into the original analog signal. There are three steps in the PCM process. First, sampling. Second, quantizing. And the third is encoding. This is the block diagram of pulse code modulation. Sampling is a process to make the signal discrete in time, so in order to reconstruct the transmitted signal without distortion, the sampling frequency must at least to maximum frequency. Quantization is a process to make the signal discrete in amplitude by rounding off to one of Q discrete levels. After encoding, quantized values are mapped to digital words that are n bit long. In the sampling process, the magnitude of the analog signal is sampled regularly at uniform intervals. The obtained values are called samples. Then, the samples will be converted to digital number, as we will see in the quantization process. So, for example, for a 4 kHz voice channel, what is the sampling rate? Sampling frequency is equal or greater than 2 maximum frequency. So, this sampling rate will be 2 times of 4 kHz, which is 8 kHz. Quantization is a process of converting an infinite number of possibilities to a finite number of conditions by rounding off the amplitudes of flat-top samples to a manageable number of levels. The samples will be rounded off to the nearest discrete level. In other words, quantization is a process of assigning the analog signal samples to a predetermined discrete levels. The number of quantization levels, L, determine the number of bits per sample, N. Quantization is divided into two types, uniform and non-uniform. In uniform quantization, the level of quantized amplitude are uniformly spaced, while non-uniform quantization, the levels are not uniform. For uniform quantization, the signal-to-noise ratio is good at high-level signals, but bad at low-level signals. That is why non-uniform quantization was introduced. Uniform quantization itself has two types, which are mid-rise and mid-rate uniform quantization. In non-uniform quantization process, the steps are not of equal size. Small steps are used for small signals values and large steps for large values. The purpose for doing so is to achieve that the signal-to-noise ratio is nearly independent of the signal levels. In other words, more code groups are assigned to speech at low levels than at high levels. However, non-uniform quantizers are difficult to make and expensive. An alternative is to first pass the speech signal through a non-linearity before quantizing with a uniform quantizer. The non-linearity causes the signal amplitude to be compressed. The input to the quantizer will have a more uniform distribution. At the receiver, the signal is expanded by an inverse to the non-linearity. The process of compressing and expanding is called compending. So, what is compending? Compending is the higher amplitude analog signals are compressed prior to transmission and then expanded in receiver. The purpose is to improve the dynamic range of a communication system. There are two types of compression methods in popular use today. There are mu laws in US and Japan, A law in Europe. Let's first look at mu law. It follows the logarithmic formula listed here with mu equals to 255. The second is called A law, follows the logarithmic formula listed here with equals to 87.6. So the last process of PCM is encoding. It is a process of representing each quantized sample by n-bit code word. Then the mapping is 1-to-1, so there is no distortion introduced by encoding. The figure at the right is PCM encoding example. Thank you for watching this video. Hit the like button if you enjoyed this video.